Dawkins, and I'm going to show you how to graph a system of linear equations. Or, sorry, linear inequalities. I'm off to a bad start. This is just some notes. If you don't have these down, you might want to jot them down before we continue. Hit the pause button first. Okay. This is the system that we're going to be graphing. They're both in slope-intercept form, so this is just an introduction. And the most important thing when you're graphing a system, and this is true whether it's an inequality or a set of equations, is you want to label your two equations. I'm going to go ahead, because I do have colors, to label them A and B. And that way, once you have graphed the lines, you can identify them with just the letters A and B. So let's start with the first one, A. My y-intercept, the blue color here. My y-intercept is 4. So I'm going to B equals 4. It's located right here. And my slope, which is located right here, is negative 2. Or, if I like to say it, it's negative 2 over 1. Let's start with this one. I'm going to begin by graphing my y-intercept, which is 4. And I always tell my students that if your graph isn't labeled, we can just assume by default it's units of 1. So this is my 4 right here. I don't really have to label it all. From my y-intercept, I'm going to go down 2 over 1. I'm going to probably do that a few times since I'll be drawing my graphs freehand. I don't have a ruler. I can't use rulers this often. All right. If you look at this inequality statement, it says less than or equal to. That's the kind you graph with a solid line. So I'm going to try and draw through here, making it too crooked. Barely okay. You've got to remember to put your arrowheads on each end. And now I've got to decide which side to shade, because you always have to shade a side when you're doing inequalities. Because this is slope-intercept form, I can use a general rule that if it's a less than or or equal to, you shade down. And if it's the other, which is the greater than or equal to, we shade up. All right. So since I have to shade down from here, I'm going to go ahead and just I'm just going to kind of use some lines to represent shading the downside of this graph. Okay. My second equation has a y-intercept of negative 1, and it has a slope of, let's call it 3, or 3 over 1. All right, let's start by graphing the y-intercept. That's negative 1. And I'm going to go slope's positive 3, so up 3 over 1, up 3 over 1. And this is going to require a dashed line. All right, which side do I shade? Well, because it's in slope-intercept form, and it's a greater than, I shade the up side. So I'm just going to draw some thin lines, so you don't really have to get that crazy. The most important thing, though, is when you are shading a system, you have to really emphasize the double shaded area. What you do is you end up creating an area that's not shaded at all. We call these areas regions. This is my unshaded region. This little triangle up here is shaded once, and that only works for one of the equations, for B. And this one's shaded once. But this area right in here that works for both, we really need to make that extra dark. Okay, that's the most important thing. And it's kind of hard with this particular software, but I'm going to go ahead and try and put some black on there. See if that'll work. Anyway, that is our region. That is the solution for both of the equations. And that's what it is for a system, all the points that make both of them work. There we go. You'd normally do this with a pencil and make it nice and dark. Okay. Oh, I've got to label my equations too. A and B. Thank you for watching.